Do you know that electron in different type of metal have different potential energy? Hi, my name is Dr. Ain. In this video, I will share with you the cell potential and reduction potential in electrochemistry. At the end of this video, we will be able to discuss the cell potential and reduction potential according to the electrochemical series, explain the spontaneous reaction of complete electrochemical cell, and calculate the standard cell potential and half reaction potential. The standard reduction potential is category known as the standard cell potential or standard electrode potential. So standard reduction potential is a voltage associated with the reduction reaction at electrode when all solutes are 1 molar and all gases are at 1 atm, 1 atmosphere with 1 molar, 1 molar mole per dm cube concentration of a solution. Okay, from the slide showed the image of the standard hydrogen electrode, She. Okay, She, a standard hydrogen electrode, is made up of the platinum electrode immersed in 1 molar of aqueous of H plus ion, so normally hydrochloric acid, and bubble with the hydrogen gas at 1 atmosphere, and the temperature is kept constant at 25 degrees Celsius. So the standard reduction potential of She, standard hydrogen electrode, is assigned exactly 0 volt. So the half cell equation for the standard hydrogen electrode is 2H plus aqueous 1 molar plus 2 electron to produce H2 gas at 1 atmosphere atm. So the E naught cell for the standard hydrogen electrode is 0 volt. Okay, now can you determine the reduction potential of zinc half cell based off the image that I show in the slide? Basically, the direction of half reactions of standard hydrogen electrode, depends on the other half cell connected to it. So standard hydrogen electrode, serve as a reference to determine the standard electrode or reduction potential of other half cell. So one tip here, the electron now move from anode to cathode through the external circuit. So in this case, zinc half cell is an anode, and standard hydrogen electrode is cathode. So can you write the half equation for anode and cathode? So can you recall about anodes and red cat? So anodes, anode, oxidation, red cat, reduction, cathode. That means at anodes happen the oxidation process and reduction happen at cathode. So based on this tip, the tip that I give, try to write the half equation at anode and cathode. Yes, correct. Now you know how to identify the element oxidized and element reduced based on the half equation at anode and cathode. You also can write the cell notation. So zinc solid produce zinc 2 plus 1 molar. This is the equation, the cell notation for anode. And then we separate with a double vertical line for sub-bridge. And then at cathode have H plus 1 molar concentration. And then we have one single line to for H2 H2 gas, and then one single line for PT electrode solid. And also you can write the net reaction. So how to write the net reaction? That means you need to combine the reaction, half reaction at anode and one and half reaction at cathode. So you need to cancel an electron at anode and cathode, and then you combine the both equation. So you get the net reaction. Okay, now, so the standard reduction potential of zinc half cell can be calculated using EMF and this for the inert cell, EMF and electromotive force. That means for inert cell. So you can calculate inert cell. So inert cathode minus inert anode. Okay. So inert cell is 0.76, positive 0.76 volt. Okay, we can see at the value at the voltmeter. So inert cell is positive 0.76 volt. So can you determine the inert cell of anode? So try to solve an equation, and given that you can get the inert cell for anode is negative 0.76 volt. Okay. Okay, next we move to, so the slide showed the standard reduction potential of different elements. So E0 is for the reaction as written based on the table given. So the more positive E0 value, the greater the tendency for the substance to be reduced. And the half cell reactions are reversible for anode and cathode. So the sign of E0 changes when the reaction is reversed. So changing the stoichiometric coefficient of half cell reaction does not change the value of E0. So this statement to remind you that the coefficient value does not change the value of E0 cell. So let's do some exercise here to calculate the standard cell potential. The question, what is the standard inert cell of an electrochemical cell made of cadmium electrode in 1 molar cadmium nitrate solution and a Cr chromium electrode in a 1 molar chromium nitrate solution? Okay, what should I do for this question? So first, try to get the info on the reduction potential of those elements. From the inert value for Cr, chromium have more negative value. For cadmium, the inert cell is negative 0.40. For chromium 3 plus, the reduction potential is negative 0.74 volt. So here, from the inert value, chromium have more negative value. So chromium have more tendency to oxidize. So from the inert value, chromium is anode and cadmium Cd is cathode. So try to write half equation at anode and cathode. Well done. At anode, chromium electrode, we lost an electron to produce chromium 3 plus. And at cathode, cadmium 2 plus in electrolyte will accept 2 electrons to produce cadmium solid. And now to cancel out an electron, so half equation at anode times 2 and half equation at cathode times 3. So net equation is 2Cr solid plus 3 cadmium 2 plus 1 molar. So produce 3 cadmium solid plus 2Cr3 plus 1 molar. Okay, next, try to calculate the inert cell for the net equation given. So you can calculate using E cathode minus E anode. So remember, you times 2 and also you times 3, the coefficient. Like I mentioned before, so the coefficient does not affect the E naught value. So you direct the value for E naught cathode is negative 0.40 minus 0.74 volt. So the inert side is 0.34 volt. I mean here the positive 0.34 volt. So you can calculate using the E cathode minus E anode. So you get the value, positive value. So the redox reaction is spontaneous when the standard cell potential is positive value. Now inert cell is positive. For the next equation is a positive value. So the redox reaction is spontaneous. But if you calculate to get the redox reaction is negative value, meaning that the redox reaction is non-spontaneous. Okay, thank you for watching this video. I hope you now know how to calculate the standard cell potential and then half reaction potential, and also you can predict the spontaneity of the redox reaction based on inert cell. Okay, if the positive value, that means the spontaneous reaction. If get the value is inert cell negative, that means the reaction is non-spontaneous. Okay, so don't forget to do an exercises related to this topic. Okay, bye. See you next video. Assalamualaikum.